Good morning, friends, or afternoon. This video is for Adrena and anybody else who has this question. Question was asked about number 1, how to find and identify the greatest common factor. So what you're going to do is you're going to divide by two things. The first thing is the biggest number, both terms can be divided by. This is called the greatest common factor. And if you don't know what that would be, sometimes it helps to list the different ways you can multiply to get both numbers. So we have 12 and 16. To multiply to get 12, we would go 1 times 12, 2 times 6, and then 3 times 4. Any of those you can multiply to get 12. Obviously, you have to multiply the right ones together. And 16, you get 1 times 16, 2 times 8. So we can see 2 is a common factor, but is it the greatest one? And then we have 4 and then 4. So 4 is the greatest common factor between 12 and 16. So what we would do is we would divide both of them by 4. Then we're going to divide by the smaller of the variable exponents. Now, sometimes it happens where not all of them have a variable. And if that's the case, then you don't need to divide. So for numbers 2 and 4, you don't need to divide by any variable because not all of them have a variable. So now this one, we're going to pick the lower one. We have n to the 5th and n third. We're going to pick n to the 3rd because that is the lower one. And whatever you divide by goes on the outside. And then you divide the numbers and subtract the exponents. So 12 divided by 4 is 3. 5 minus 3 gives you 2. And then for the next one, 16 divided by 4 gives you 4. And then 3 minus 3 is 0. So that one cancels out completely. So that is how you factor by greatest common factor. Now the other questions are asked about 37, 38, and 39. And I totally understand challenging. So for 37, you want to write two complex numbers that add up to 17 minus 12i. So this one is not that bad. When you do these, you just have to remember all complex numbers have a real part and an imaginary part. And when you're adding and subtracting, the real goes with the real and the imaginary goes with the imaginary. So we can kind of view this separately for now. So we want to come up with two numbers that add to be 17. So to add to be 17, we could get, I don't know, my brain thinks of 10 and 7, right? 10 plus 7 is 17. You could have other options there. You could have 9 and 8. Let's see. 7 and 10 we just did. 11 and 6. Just keep playing around with it. Then you got to think of two numbers that are going to add to be negative 12. So my brain just thinks make them both negative. That would be the easiest. I would go maybe negative 10i and then a negative 2i. Negative 10 plus negative 2 would give you negative 12. And you don't need to worry about doing anything with the I. It just comes along for the ride. 38 is the same way. You can view it separate, right? You got to think of two numbers that subtract to be 25. So maybe... Oh goodness, no, we gotta be careful because we're gonna have to subtract the whole thing. So we gotta list it correctly. So let's see, what subtracts to be 25? So I'm just gonna pick a number to start with because I don't like doing There we go. I'm going to start easy. Maybe go by fives. So 30 minus 5 would give you 25. Okay? That's one way. You could do any numbers there. And then 19, I would maybe go, let's see, we'll go, I don't know, I'm just going to keep it real simple. 20i minus 1i. Oh, and it's already a minus in the middle, so we got to make sure we list that as a plus, because remember, you're going to be distributing that negative. Okay? So you can just view it kind of separately, because that's it's a little tricky with these, right? Because let's say with regular numbers, if you want to come up with what multiplies to be a regular number, like if we did 25, let's say I would pick, I don't know, 5. Let's say we don't know that. Or let's say we're going to be crazy and do 25 is kind of a weird one because there's not that many numbers that multiply to be 25. It's pretty standard. Oh, excuse me. So if I was just figuring out the numbers, I would go 25 divided by 5, and that would tell me 5 times 5 is 25. Little different with complex numbers. I'm just going to pick a complex number, and we're going to keep it simple. So I'm going to pick, I don't know, 1 plus I. You could even do 1 plus 2i. I'll do 2i here because you'll kind of see this is a good one for this one. 1 plus 2i. I'm going to divide it because that's going to tell me what other complex number I would need to multiply by. So I just picked this. Some examples of a good pick would be maybe 1 plus I because it's super simple. 2 plus 2i. 2 plus I. Play around with it. Any of those. I would not go any higher than that personally. Okay, so now the technique that you use to divide with a complex number is you actually have to do something called rationalizing. We're going to take what's on the bottom and we're going to multiply by the conjugate of it because that is how you divide with complex numbers. And then the top is going to get distributed, so we would have 25 minus 50i. And then the bottom, you have to use that FOIL technique or the box method. So we have 1 and 2i and 1 and negative 2i. And then 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is 2i. And then this gives you negative 4i squared. Now these guys are opposites, so they're going to cancel. And remember, you guys, I squared is the same as negative 1. So we're just going to replace it and then multiply. Right? Yes. Yeah, okay, I don't know why I'm pausing at that. So then what we would do is we would add them together. I think I did something weird with that. Let me try the foiling method. 1, negative 2, and then negative 4i squared. Yeah, no, that's good. I don't know. Okay. So then I swear in the answer key I got 5 when I did that. Maybe I forgot the negative. That could be on me. Okay, so anyway, when you add these terms together, you're going to get 6. So then our final step, you could leave it like that, or you would actually divide each of those by 6. This is why I paused for a minute, because I could have sworn I got 5, and it divided real nicely. I wonder if I forgot a negative. I will double check that. But you get 4.2 minus 8.3i. So you could certainly do it like that, or you could just leave it together like that. That's fine. But you're going to get weird answers-ish. Yeah, these are tricky questions. You could also kind of play around with it. You guys know the idea of conjugates is how you cancel things and get plain numbers. So there's lots of ways. You could even do sneaky sneaks and say, well, if I have a 6 plus 0i and a negative 6 plus 0i, see what that gets you. Play around with it. But yeah, that is one way to do it.